Welcome to Data Skeptic, a podcast exploring the methods, use cases, and consequences of recommender systems. Welcome to Data Skeptic Recommender Systems. Are you one of those people that was upset when Netflix went from 5 stars to just thumbs up, thumbs down? I'm told that's an episode of The Big Bang Theory. They didn't ask me, clearly, because I don't approve of it. Doesn't a larger cardinality give me more information gain? Can I not express myself more with 5 than with 2? I guess I'm not trusted to do that. But it makes me thumbs up and thumbs down in weird ways, or maybe hesitate. Does thumbs down mean I don't like it, or I don't want it right now? Or I don't like this particular one, but show me more like this in the future? Versus I dislike the whole category? Today we're going to discuss the paper, Give Users the Wheel. This is a proposed hybrid approach, and in my opinion, a bit of a vision for next generation recommender systems that I hope take off. Let's get into it.
My name is Fuyuan Liu. I'm currently a final year PhD in McGill and Mila Quebec AI Institute.
Can you share a few details on what you're studying in your PhD?
Mostly, I was studying on recommendation system and how things are utilized in recommendation systems. But now, as I'm moving more and more senior, I see more and more recommendation as one specific area, a domain-specific area, and how general technique can be applied beyond recommendations.
How did you first take an interest in recommendation systems?
It's very coincident because I joined an internship the second year of my PhD. So actually, everyone was using the recommendation system. So it's sort of the first thing that you interact with the technical sectors. But the formal version of why I get started in recommendation system was the second year of my PhD. I joined an internship, and that completely shaped my interest.
Could you share a few details on it? What was the project you were brought on?
The project I was brought on is more doing CTR predictions, because previously I sort of shift my research interest. At the beginning of my PhD, I was doing neural architecture search and AutoML. And at the time of 2019 and 2020, when people just realized that transformers are going to unify everything and people just shift to transformers. And I feel a bit down at the beginning of the internship because I was sort of impacted by that directions. But then I realized that in a lot of real-world applications, such as recommendation, the real power of AutoML on neural architecture search does not lie on how you search on the model space, but how you search on the feature space. Because the feature itself are very domain-specific and there is no unified way of doing that. And how do we provide a systematic way to alleviate human beings from the repetitive effort of feature engineering? Because previously people relied on feature engineering a lot. Experts choice, this kind of stuff, to make the performance do good and make their model performs good. But then I realized that as the systems are evolving and as the scenario are getting more and more complex in our real life, we sort of need a systematic way to automate some part of things. And my first work was trying to automate one of the key in feature interaction, the key in recommendation or CTR prediction, which is the key name in advertisement, is feature interaction.
So the primary paper I invited you on to discuss is titled, Give Users the Wheel. What wheel are you giving them?
So it's all come from my personal experience because I was a heavy Bilibili user. Bilibili was basically Chinese version of YouTube. So in Bilibili, basically I have 2 modes. So it's really personal. So the one mode is when I wake up in the morning or say in the afternoon, I was trying to be more informed of what's happening in the world. What's the latest news in the technology sectors or what happened with the global event, what are the major news. But after 8 p.m., I was sort of shift into another mode, which I was just interested in dogs and cats and funny videos. So because my interest was quite split across time zone, so I was thinking, so I wouldn't explicitly, say I dislike this video. There's a small button also on Bilibili, as I think there's basically any recommendation platform saying that I don't want to see these models. But every time the feedback of I don't want to see this kind of video was reflected on the other day, the morning time. For example, at night, I say I don't want to see anything tech related, informative. Then the other day, they just keep recommending me cat in the morning. So that gave me to say that is it possible that we can just give explicit requirement to recommendation system saying that I don't want to see anything series after 8 p.m. Until midnight, so that the user could have much better experience in the recommendation system. That's the initial intent of this paper.
Well, historically, and by that I mean before large language models, I feel like this would have been a great challenge. You would have to build some sort of, user interface where you could give the user feedback, or maybe a more complicated feedback tool like, I like it, I would like it at another time, it's something, a richer space there perhaps. But what do LLMs unlock in this opportunity?
I think the LLM, from our recommendation domain, LLM, what really unlock is the UI interface. So we don't need to worry anymore about the UI, because we can just simply have a chatbot at the bottom of any recommendation system that can receive the user's instructions easily. And user does not need to learn anything about that UI, because they were just typing as they were typing to a natural human being or other chatbots, Gemini or GPT. So that gives we, the recommendation community, a lot of chances to deliberate nuance control given the user's feedback directly on the recommendation systems. So that's what I think that completely eliminated some sort of greatly alleviate us of the burden of designing UI and HCI studies.
And do you have any thoughts on what common prompts you were expecting to use or hoping that would work in your framework?
In the framework, what we would really use was very simple prompt, because we sort of create our own evaluation set. We use 40 prompts. Most of them are I don't want to see anything like this, or I dislike this kind of thing, or I want to see more, blah, blah, blah right now. So it's sort of LLM generative, naive instruction, which only contain one instruction per prompt. But in the future, we are expecting more nuanced scenarios. For example, I want to see action movie, but I don't want to see anything bloody inside the action movie. So it's more like a combination of the prompt. The even more challenging one was the one with the temporal or spatial information. For example, I don't want to see anything informative at home or anything serious after 7 p.m. These are the more challenging ones.
Is your goal to replace traditional recommender systems with LLMs, or is it a hybrid model you have in your vision?
In my vision, was more like a hybrid model, because when you check the user's habit on TikTok, on YouTube, this has been the habit that has been cultivated for years. I think YouTube had maybe 20 years, something like that. So it's very hard for you to say that, we have a LLM-powered model, and we only interface we give you is a chatbot, and it can say anything you want, or the LLM will recommend you with something daily sometime. So it's very silly. And the second thing is, for we, the user, recommendation sort of built a very informative way of conveying information to the user. For example, you open your TikTok or you open your YouTube on your mobile, you see more than one video at the same time, right? You can see multiple videos at different chunks. Because we humans fundamentally are visual animals, 60% of our information are conveyed in the visual way. So in this way, we don't need to necessarily replace, or it would be reinventing the wheel if we completely replace the current UI, but more instead, we should give the user more control. That's what we titled Give User the Will.
Yeah, I have personally been frustrated with the sort of crudeness of thumbs up, thumbs down. It doesn't really express the totality of the feedback I might like to give a system. So I like the idea of including an LLM in there, but it's not yet clear to me how these things glue together. I'm not going to say, go into the feature space and do something with the eigenvectors or tell it what to do in terms of matrix factorization. How do you get the traditional methods to get an advantage through an LLM?
Let me go a bit tech detail here.
Yes, please. Yeah.
So from our perspective, the LLM has been emerging, I think, 2023, right? And the weak recommendation community sort of noticed that at the very beginning. People they were doing more initial trial, can recommendation, given the user's history, can recommend ChatGPT give me some recommendation, what this user will like in the future, right? So that's the initial trial. And as people move forward after this kind of studies, people realize that, LLM really don't have this kind of collaborative filtering abilities, and we sort of need to enhance that, or otherwise we're losing the advantage of the recommendation. So after that, people have mainly tried two ways from my perspective. So one way is that they sort of merging the collaborative filtering information into LLM to give user more nuanced control. Well, that was very intuitive way because we just treat collaborative filtering information as other post-training informations that can be fused into the language models. Another way was more industrial thinking from my perspective, was that we still give collaborative filtering, using the collaborative filtering to do the ranking stage of the models, which means that we can generate hundreds of candidates. But the user's requests are equally important. So we, among these hundreds of items, we sort of extract the items that mostly align with users' request in the prompt. So that basically sort of replace the re-ranker of the existing industrial models. But our model was more try to be more broad and revolutionized, if I call that, is that we want to fuse all the recommendation collaborative filtering in the ranking stage. But in the meantime, we want to deliver the nuance control and utilize the hidden information in the collaborative filtering. For example, the expected way of conveying information is that I gave the recommendation LLM one command saying that I want to see more cat and dog tonight, animal-related videos. And the LLM sort of understands that prompt, and that prompt was embedded into a hidden vector, and that hidden vector can be completely reused during the whole night's recommendation. So in this way, we only need to go through the language model once and get their embeddings, and the rest of them will leave it to the conventional collaborative filtering or recommendation models.
So I think we've been describing DPR, the Decoupled Promptable Sequential Recommendation Framework. Is that right?
Yes.
And I know we covered it there, but let's go into a little more detail. Can you give listeners a sense of what's under the umbrella of this framework?
So it's very easy. So we start for the language model part, we didn't do any addition. We just adopt off-the-shelf Hugging Face models, use their embeddings. For the recommendation part, we also didn't touch it too much. We use SASREC, GRU for Rex, this kind of static, industrial standard sequential recommendation models. What we really do is at the fusion stage. So we have, after the recommendation, going through the user collaborative filtering information and going through the user's prompt, we have two hidden representations. One is the one from recommendation models that represent users' historical interests. The other one was the one with users' intuitive instruction or intermediate instructions right now. So we have to find a way to fusing these two. So originally we thought, maybe we can just train, a transformer or a self-attention module on that, and that can easily get you the result. But turns out we are wrong. So we are very, very much wrong because the user's instructions are very nuanced. And in the experiment, we only consider two kind of instructions. One is is a positive instruction, we call it, means that I want to see more, I like this more, show me more, this kind of thing. The other thing is negative instruction or suppression instructions, saying that do not show me anything like this. So these two instructions behave completely differently in terms of the hidden space. It's sort of linking with the machine learning and machine unlearning in the neural community, right? So these are very hot terms in ML communities or ML conferences. So in this way, we have to do sort of a routing or MOE, what we call it. In the plain English, we just split this two kind of instructions into two attention modules. And that way, after that, we still decode the users, the recommended item to the users, the same way as we decoded the SASREC. So it's for we remove the last layer of the SASREC or other sequential recommendation model, we put it up, and we insert the language model and the fusion module in between, and then we decode in the same way. So from the user perspective, apart from giving one instructions, everything was behave the same. And the best part of that is that we can even decode without any user instruction. So we have the same module that encodes all the user's historical informations. Whether we add that instruction was optional.
And I don't know if we've touched on all three stages of the model, but could you at least outline the stages the data goes through?
Oh, the first stage was more like train the SaaS-RAG. That's nothing special. The second stage is that we give the recommendation model the user's instructions, and we try to tune this kind of modules. The third stage is what we call enhancement stage, is that we realize that there is no unified way of aligning user how they type to language model, right? So we explicitly need to add a nuanced control using a different training way. And that user control, like that user instructions, was sort of similar to existing user instructions, but was rewritten by a language model deliberately to enhance the diversity of the model, to make sure that we are aligning to users' real interest, but not the specific words like the way that they type or the way that they convey their information in the models.
How do you end up going about evaluating the framework?
That's the hardest part of actually our model, because we don't have any data set that look even closely to what we want to evaluate. So in the end, we have to construct our data set by ourselves. So the way we adopted was sort of academia. It doesn't necessarily scale to real world, but we'll try to make it more and more realistic and close to what user really want. Back to the evaluation is that we have all this kind of recommendation data set, and we can extract the user's request, and we can manually design some heuristic to alter the user's future sequence. For example, the user in the movie lens data set, we can say that from certain time point, the user is going to only watch action movie or romantic movie, and we can discard all the other movies that the user watched in the user history. In this way, we sort of manually change the user distribution in their item sequence, right? And given that heuristic we applied, we can generate the prompt that users say that I want more romantic movie or more action movie from the time point when we alter the user sequence history. So in the real world, it should be like user gives the request and we record their actions in the item space. But in our way, we have to do it reversely. We first alter the action space, and then we use a heuristic or all the metadata of the items to generate the user prompt.
And I assume many listeners will already be familiar with the famous Movie Lens dataset that I know you did some work with.
Yeah.
I don't know if everyone is going to know the Mind dataset. Could you give some background on it?
Oh, the Mind dataset was a news recommendation dataset that contains certain, three level of tags. Tags would mean it's similar to action to Movie Lens. For example, sports or geopolitics. This kind of tags on that systems. And it's more hierarchical. It contains three levels. So I think we mostly use the second tier level of the tags.
So you've got two pretty different data sets to experiment on, and you applied your approach there to some benchmarks. Could you talk about the performance?
I think the performance, the most easy way was to go to my paper and check it, but I can briefly talk it here. So I think what we have is for the sequential recommendations, the conventional sequential recommendations, we have a way of, because we didn't want to perturb or disturb the original well-trained recommendation model under the normal situation, so we apply really small learning rate there. And we witnessed a slight improvement in terms of the against the original performance. So it's sort of a warm-up setup. So we know that in machine learning, people usually do not a warm-up learning rate reduction. So people reduce the learning reduction to reduce the exact inform. So we sort of unintentionally achieve that because we assign small learning rate to that. But the sequential recommendation is beyond our topic. We are more concerning about the positive and negative scenarios. For the positive scenarios, the result we have was really good. We compared several baselines. So one of the most important baseline is that we tune the model in the exact same way as we do in the training the promptable or DPR models, except that we didn't give them the language model embedding. So in that way, the recommendation model sees the exact same user distribution. So make sure that we are not like comparing apple to orange. And after that, we had a heuristic filter because we have the way we construct the user prompt give us the options to filter out certain items, right? And in the output recommendation, we filter out output items in a heuristic way exactly as we alter the data. So that way, we think this is a strong baseline. And DPR, surprisingly, can significantly surpass that baseline. That is beyond our suppression, beyond our expectation. What we interpret from that is because the DPR encodes the instructions, the user's instruction in a very nuanced recommendation ways, they sort of stimulate or amplify the user hidden representation in the later stage. And in the previous models, because we alter the distribution and we apply them heuristically, so they still do in the more coarse-grained control, but DPR was doing more fine-grained control. And of course, if we do fine-grained control well, we are surpass the coarse-grained control. For the negative one, which means that we say to the user that we don't want anything, that one was a bit surprising to us because we didn't get the best information, not consistently the best information as a positive one. In the statistical sense, outperform the baselines, but there are certain cases, for example, on certain matrix, on certain cases, that the filter method I talked earlier surpass our model slightly. So this marks very interesting changes, as I described earlier, because the machine learning stage, because in the suppression or in the negative cases, basically we are asking the model to temporarily forget what they learned in the previous stage. And that forget, or what they forget, was explicitly stated by the users. So it's sort of a high level reasoning. It requires sort of a reasoning capability to do that. And if we want to do this in a machine learning way, we sort of need more nuanced architecture to design to suppress that. Current way of doing that, we can achieve sort of improvement, like much more improvement compared with other baselines. But regarding the filtering baseline, that was doing the heuristic way is still the most stable and comparable way to us.
Is it true that the DPR framework is, trying to think of how I would ask this, I guess modular, that maybe you do some classic recommender system and then the language model comes around and reorders or maybe amplifies or de-amplifies what it's presented from the first stage? Is that a correct description?
That is the correct way of describing that. But what we different from the previous one is that we operate them on the hidden representation space. We didn't operate them on the item space.
I've seen some rollouts of LLMs, not necessarily in recommender systems, but a technique I see used is sometimes you get the user's prompt, and then there's like a behind-the-scenes prompt that says, okay, this is what the user said. What is a better prompt that we should pass along forward? Do you think that's necessary, or will most people have pretty intuitive and immediately useful requests of the system?
I think if you're talking about an online system that directly applies to the users, then the system prompt is something absolutely necessary. First of all, you need to sort of control the behavior of the user. Certain like violence command, you should exclude that, or you should find a way to neutralize that. And also, you need to system prompt to give user much better experience than what user prompt themselves. But in the current stage, we did not consider system prompt at all because we think that even though if you get a good system prompt, you can always get some good results out of the box. But in the research stage, we sort of need to do more modular and control experiment. So we only use the exact same prompt that user gave, which is the way that we created earlier. We talked about.
Well, you have some very positive results shown in the paper. What do you think are the steps or maybe the barriers to us seeing it in some real-world applications? Like I'll go to YouTube and suddenly there'll be a little chatbot there that's based on a framework like yours.
I think there are several ones from the technical side. Just negative suppression is the one that are mostly important to us. So because that one we're planning to solve in our next project, next papers. That one, without solving that one, we might as well, just using the heuristic way of doing filtering. The second thing is that as we put that feature online, users are going to give you more and more complex features. For example, the combination prompt with more with both negative and positive. For example, I want action movie, but I don't want to see anything blood. So this is kind of a statement. How do we decompose that? And you still make our current separation of positive negative work is something we need to consider about. And also the temporal and spatial requirement that needs to encode the language model with more nuanced ability to understand time and space. But that is sort of we can leave that to the language model and NLP community to solve that, because there has been a lot of amazing researcher doing amazing work in their community to try to make sure the language model is aware of time and space. So this is more from the technical side, what I anticipate. But from the user side, or from the, say, legal side, we may need to consider to reassure the user about their privacy, about how their instruction will be used, how their things will be used only to enhance their user experience, but not on doing something other unintended or unspecified issues.
So you'd mentioned privacy. There's always, I guess, the promise you can make that we won't hold your data. And hopefully when a company says that, they're truthful about it. Are you thinking it's just a commitment to privacy, or are you interested in something a little fancier like federated learning or something privacy in an interesting computer science way?
I think from our perspective, the module itself can be decomposed in a way. For example, as we see, I know there is one module called JimmyChat.ai. There is a group of basically startup, not trying to attack them, but basically a startup trying to directly code the language model weights on a silicon chip and deliver 20 times faster serving rate, like token per second, compared with GPU, what we're using on GPT or Gemini Daily. So what I anticipate in the arm of my framework in the future might be that, for example, for the language model encoding part, we can leave that to our cell phone by themselves, because in a day that as the time passes and as the module gets smarter and smarter, and we find more energy efficient way to compute that, we can sort of offload that compute into the cell phones themselves, so that the user's very nuanced control or nuanced prompt or system was not revealed to the service provider, and we can simply provide them with a representation that we can apply, federated learning or differential privacy, this kind of thing, on that representation, so that without hurting the user performance, we can still achieve good user satisfaction. So that's what I anticipate given the current framework. But of course, we need to solve many, many tech barriers I mentioned earlier.
All fun stuff, though, for sure. This may be a little out of scope, but do you have any thoughts on how DPR will interact with the cold start problem?
That's a very interesting way of saying that, because the cold start problem is what we expect that DPR can sort of alleviate, but we haven't do much rigorous study on that. So what we anticipate really is that maybe because currently the way that we solve the cold start is more rely on the user metadata. We get the profile of the users and we try to describe it as much as possible, as detailed as possible, and we cross-reference that with other users in our database and try to say that, well, maybe this category of users like this kind of thing at the beginning of the model, and we try to collect data and try to improve iteratively. But instead of collecting that user profile and guess their interest implicitly, why don't we just give them a question and ask them implicitly? We see several ways of doing that, in the instructions. But that was more like tag-based. For example, I give you dozens of tags and try to select what you are interested in. But maybe we can do more nuanced control, but asking user questions, do you prefer action over romance, or more nuanced, like, do you like this specific movie or not? Or have you watched this specific movie? And how do you comment on that? And from that, we can more explicitly get users' interest and solve the cold start problems.
Well, you've looked at it, at least in the paper, from the perspective of movie recommendations and news recommendations. Do you think that the framework is likely to generalize to everything, or are there maybe particular domains you're interested in applying it to?
Currently, we are trying to apply the proposal framework as a general framework to all the setups. But from my expectation, that model is not going to work on movie. The reason that it doesn't work on movie is nothing related with technical sector, but the way that people consume movies. basically we can afford to say we check the movie list for 10 minutes and we recommend or see the movie with our family like for 2 hours. So that sort of setup gave user much more tolerance on controlling what they want. So they didn't require real-time control. And so in that way, from my perspective, the movie recommendation can be completely replaced sort of with a chatbot, or heavily replaced by a chatbot that can access your user history, and give you questions, or you can give their feedback give the feedback to you, to the chatbot. But what I expect the DPR gonna work is something more in time, such as newsfeed, this kind of thing that you cannot afford. Say I chatted with a model for 10 minutes or 5 minutes or 3 minutes, and then it show me like 30 seconds TikTok video. That would be very silly for the users. What they really want is that I chat with the model for 1 minute, and for the next hour, I don't need to worry about the model. I can just like immerse in the TikTok feed and just scroll and scroll and scroll. For news, it's the same. Like I want more, like say, config the model maybe once per day, like 30 seconds. I just give them a prompt, and for the rest of the day, I can just rely on my historical data and the previous instructions, and the news will just give me the information that I need at the time I need it. So what I expected that the DPR or prompt recommendation work is working on this kind of working on this kind of system where a user has much more intense interaction with the system, unlike the movie lens.
Do you have a prediction for how close we are to having tangible consumer tools like the ones you're describing? I want this. When can I get it?
I think that depends on how much intention can I get from the community, or how soon people realize that. I think that the current language model and the current, this kind of technical barrier I mentioned was not a severe bottleneck. So that's nothing like GPT-5 to GPT-3. That's not unsolvable technique from the perspective right now. What we anticipate is that when the recommendation community realize that this could be a way of doing that, and after realize that, I expect 1 to 2 years for the research community to fully explore the problems of this kind of thing. And to move that online, I expect maybe at the end of the second year, something like that.
And what's next for you?
As I mentioned earlier, I'm currently more interested in saying that using language model as a more nuanced controller, specific detail setups, for example, prediction models, recommendation models, various kinds of models. The reason that I'm interested is that because I have a recommendation background, so we have a sort of a very mature pipeline of how do we interact with users and how we collect feedbacks and how we do that. But that nuance model or that nuance pipeline or mature pipeline does not see a place where language model can fit in. We either currently mostly tend to replace one of the two models completely with a language model or with other techniques, which I may have some humble doubts on that. What I expect is that language model is more like a controller to control what we do right now on the nuance space. And that philosophy, I think that should not be only applied on recommendation, but more on other prediction tasks, such as finance or healthcare. For example, in the healthcare, the user specifically describe what they're feeling right now. And based on the user historical healthcare data, we can more accurately predict user going to experience some disease, or should we recommend them to go to the doctors or go to the ERs. So these are the things that I was trying to see. So I'm trying not to limit myself to one specific domains. As I have more and more collaborators, I will try to align this philosophy to more domains. Because the reason that I want to do this, I expect that different domains are going to have their own unique problem. For example, healthcare data are going to be very much different from recommendation data. But as we align the same philosophy to that domains, we realize that where the philosophy are, so that we can merge this feedback from different domains to get a more better version of DPR or this kind of language model as a controller over deep learning models, this kind of paradigm.
And do you have any plans for post-graduation?
So currently I'm in finance. I'm trying to apply that using the alternative data into the deep learning model and trying to see how that can work. In the meantime, I'm trying to work with our lab peers, my lab peers, and my other collaborators, and try to get their feedback on their specific domains, how this kind of paradigm was working.
And is there anywhere listeners can follow you online?
Oh, you can just follow me on LinkedIn, or you can send me an email anytime you want. Basically, I have all my research-related material on my personal website. They can all more than happy to go and download. I try to open source as much details as possible.
Very cool. We'll have links to your site in the show notes for listeners who want to follow up then.
Thank you. Thank you for the advertisement.
Yeah. And thank you so much for taking the time to come on and share your work.
Thank you, Kerry. Nice talking to you.